Okay, so in this video, we're going to go through page 76, which is inscribed angles. So we've seen central angles of circles, and those are angles where the vertex is at the center. So notice that in this situation, an inscribed angle is an angle whose vertex is on the circle. So each part of the angle, each endpoint is on the circle, rather than a piece being the radius. So there is a different relationship between the arc and the inscribed angle in this situation. So the measure of an inscribed angle is half the measure of the intercepted arc. So what that means is that in this diagram, the measure of angle ABC is half the measure of the arc. So in this case, the arc is arc AC. So that means that the measure of that angle is half the measure of arc AC. So say that arc AC was 100 degrees. That would mean that angle ABC is 50 degrees. Okay, so that's the relationship between an inscribed angle and the arc that it opens up to. So because of that, if I have two different inscribed angles that share the same intercepted arc, that those two inscribed angles are equal. And we can actually look at this diagram in two different ways. For the first one, I'm going to look at the two angles ABC and angle, I should switch colors, and angle ADC. So notice that both of these two angles open up to arc AC. So because they both share that arc, that means that those two angles must be congruent. So their measures must be equal. So the measure of angle ABC is actually equal to the measure of angle ADC. So then for the last one, if I have a quadrilateral that's inscribed inside of a circle, so if I have a quadrilateral who all four vertices are on the circle, then opposite angles are supplementary. So what that means is that the angles that are opposite one another, so B and D, or A and C, those angles are supplementary. Remember, supplementary means that they add to 180 degrees. So that means that the measure of angle A plus the measure of angle C is 180 degrees. And for the same property, the measure of angle B plus the measure of angle D is 180 degrees. So opposite angles, angles across from one another in the quadrilateral, are supplementary angles. Okay, so let's look inside and do some problems. So these are going to go straight across as we go along. And again, they'll start a little more simple, and then we'll throw in some variables and further steps. So for the first one, we're just straight out using the property, the relationship between the arc and the inscribed angle. So the inscribed angle WXY is this angle here. And so that's going to be half of the arc. So that value here is going to equal 1/2 of the arc, which is 62 degrees. And so that means that that measures 31 degrees. Okay, so 2, we have an inscribed angle. It's actually kind of turned into a triangle. And so what we're looking for here is angle PQR. So angle PQR is this angle here. One thing to notice is that because this PR is the diameter, that means that the measure of arc PR is 180. Okay, so if I know that this large arc is 180 degrees and my angle PQR is an inscribed angle that opens up to that, that means that that's going to be equal to 1/2 of that 180 degrees. So that means the measure of angle PQR must be 90 degrees. Okay, so for number 3, they're asking us for the measure of an arc. And they've given us an angle. So BC, the arc they want is this arc here. Okay, so this is what we're trying to figure out. Looking at the diagram, one thing that we can figure out is the arc next to it, because we know that this angle ABC, is 47. So this is like the opposite of the last 2 problems. So remember, if I divided by 2 or multiplied by 1/2 to find the angle, that means I'm going to multiply by 2 to get this arc. So this arc here is 2 times 47, which is 94 degrees. Another thing to notice is that AB is the diameter. So that means that this whole arc here is 180 degrees because it's cutting that circle in half. So that means that to get my answer, I just have to take that 180 and take away the 94, and that will give me the value for arc BC. So that means that arc BC is 86 degrees. Okay, so things are getting more complicated, as we can see. Okay, so for this one, I'm trying to find the measure of angle RST. So RST is this guy here. They also want us to find the measure of angle RUT. So what we should notice is that RST and RUT both open up to the arc RT. So if we find the arc RT, we just have to take half of that to find both of these angles. So we can see that because they both open up to that same arc, they're actually congruent. So once I find one of them, I'm finding the other. Notice that they give us all the degree measures around the circle. So if I want to find the measure of arc RT, all I have to do is take 360 and subtract these values. So if I subtract 64 and I subtract 139 and I subtract 75, that gives us that the measure of arc RT is 82 degrees. So if this guy then is 82, and these are inscribed angles, that means that both of these angles are going to be half of that 82 degrees. So if I divide 82 by 2, that gives us 41 degrees for both of these angles, again, because they open up to that same arc, arc RT. Okay, so for number 5, we still have inscribed angles. We don't have any quadrilaterals yet until the end, but now we're throwing in variable expressions. So if we think about the relationship here, the arc is double the inscribed angle. So if I know that this is 67, that tells me that this arc is 2 times 67. Okay, so I know that the arc must be 134 degrees. So if I take the expression that they've given me for the arc, which is 4x plus 58, and I set that equal to 134 because I know it must be 134 degrees because of that inscribed angle of 67, then I can solve for x. So we want to subtract 58 from both sides. So that gives us that 4x is going to be equal to 76. And then dividing both sides by 4 tells us that x is 19. And it was just asking us to solve for x, so that is our solution. Okay, so then for number 6, we still want to solve for x. So x is this arc over here. And then we know that one arc on the circle is 120, and we're given this inscribed angle again, and so we actually can tell that then this arc here is 134, again, because that's 67, we just did 2 times 67. So I don't need to try to multiply that out again. So if I know a measure or an expression for every arc around the circle, what I can do with those is add them all up and set that equal to 360. So since it's the whole circle, so I know everything, I can take that sum and set it equal to 360 degrees. So I have 120 degrees plus 134 degrees plus my expression 5x plus 21 degrees. And so I can use that to solve for x. So if I combine like terms on the left side, so if I add up all these degree measures, that gives us 5x plus 275 is equal to 360. So then subtracting 275 from each side yields that 5x is equal to 85. And again, we're just solving for x, so this will be our answer. Dividing both sides by 5 tells us that x is 17. Okay, so then for number 7, we've got a triangle happening. And remember that when this piece is the diameter, that's giving us that this arc is 180. So that's telling us that this is half of the circle. And so since I know that this whole arc is 180 degrees and x is inside this inscribed angle, I know that that piece then is half of that 180. So I know that that must be 90 degrees. So what I can do, just like we did in the problem 5, we knew what the arc was and we had an expression for it. Now we figured out what the inscribed angle is. It's 90 and we have an expression for it. We can solve for x by setting those two equal to one another. So we've got the 13x minus 1. We know that that must be 90. So if we solve this for x, and then divide by 13, that gives us that x is 7. And again, the problems here look like they're all, except for number 10, are asking us to just solve for x. So that is our answer. Then for number 8, we want to find x inside an inscribed angle. And so like we did in 7, we need to know the measure of that arc. So what we have to do then is subtract the other measures of the arc. So we know the other 2 measures of the arcs from this circle. So we have to do 360 and subtract the other 2 arcs. So minus 92 minus 162. So that we can find that value. So since that gives us 106, I know that this arc is 106. And again, if the arc is 106, that tells us that the inscribed angle is half of 106. So that means that that value is 53 degrees. So that means that this is a 53-degree angle. So what we can do is now we can set the expression equal to 53 and solve for x. So we know that the expression 7x minus 10 represents that inscribed angle. So if 7x minus 10 is equal to 53, then we want to add 10 to both sides. So that 7x is equal to 63. And then dividing by 7 gives us that x must be 9. Dividing by 7. All right, so last 4. For number 9, they want us to solve for x. So we have 2 different inscribed angles. So if I look at these 2 inscribed angles, I know that angle CBD is 52 degrees, and I know that angle CAD is 3x minus 8 degrees. Because these 2 angles both open up to arc CD, I know that they must be equal. So that means that we can take 52 and set it equal to 3x minus 8 because they open up to the same arc. So to solve for x, we would want to add 8 to both sides. So 60 is equal to 3x, and then dividing both sides by 3, let us know that x is 20. Number 10 involves a similar picture where I have 2 inscribed angles that I'm given. So I'm given that angle VSR is the expression 5x plus 23. And I'm given that angle VTR is the expression 9x minus 27. Both of these angles open up to arc VR. And so that means that those 2 inscribed angles are congruent. So I can take 5x plus 23 and set that equal to 9x minus 27. This question is asking us to find the measure of arc RT. So it is going to take a little bit extra work to get there. So let's just solve for x first so that we can find the measure of those angles, and then we'll kind of go from there. So if I solve this, I want to move all the variables to the same side. So let's subtract 5x. And then add 27. So that gives us that 50 is equal to 4x. And by dividing by 4, that gives us that x is 50 divided by 4 is 12.5. So there's a couple things to notice here is that what I can do is I can find either one of these angles. It doesn't really matter which one I find. So if I find the measure of angle RSV, that's the same as the measure of angle RTV. And either way, I can plug into either one. I'm just going to plug into the one with the 5. So 5 times 12.5 plus 23 is going to give me the measure of both of those angles. And so by plugging that value in, that tells us that those angles measure 85.5 degrees. So each of these are 85.5. Because of that, what we can figure out from here is the arc across from them. It's not the arc that we need because we need arc RT, but we can find the measure of arc RV because it's just double the inscribed angle. So that means that if I multiply the 85.5 by 2, that's going to give us that arc measure, which gives us 171. So that's going to be 171 degrees there. Notice that we do have a diameter in this diagram. So since VT is the diameter, that means that this whole arc from V to T is 180 degrees. So RT is going to be equal to 180 minus that 171. So that means that the measure of arc RT is 9 degrees for this problem. Okay, so for our last two, we're looking at a quadrilateral inscribed in a circle. And so that allows us to tell that opposite angles are supplementary. So I know that these two angles are supplementary and that these two angles are supplementary. So since I have a mark for both of the ones that I pointed to in blue, I know that angle E is 68 degrees and I know that angle G is 9x minus 5. I can use that to solve. So 68 is equal to 9x minus, sorry, it is not equal, it's supplementary. So 68 plus 9x minus 5 is supplementary, so it's equal to 180 degrees. So if I combine my like terms, that's going to give me 9x. 68 minus 5 is 63. So 9x plus 63 is equal to 180. So if we subtract 63 from both sides, (9x) is equal to 117. Again, this is just asking us for x. So if we divide both sides by 9, x is 13. So for number 12, we have a quadrilateral again. So remember about our supplementary angles. Since I have angle L labeled, if I can find angle N, that will allow me to use their sum is equal to 180. So I know that angle L is 15x minus 23. What I need to find next is whatever the value of angle N is. And so I do have enough information using the arc here. So if I have this arc from O to M, and I know that two parts of it, it's 91 and 135, then I know that their sum is 226 degrees. So remember that the arc and the inscribed angle have a relationship of half. So that means that for N, I just have to take half of 226. And so that will be the measure of angle N. So that means that angle N must be 113. Okay. So So if I combine like terms, I want to subtract 23 from 113. So 15x plus 90 is equal to 180 degrees. And then if I subtract 90 from both sides, that gives us that 15x equals 90. And then if I divide 90 by 15, that gives us that x is equal to 6. Okay, so that is inscribed angles and quadrilaterals inscribed inside circles. Remember that kind of the big idea here is that an inscribed angles measure is half the measure of the arc, or you can think about it as the arc is double the measure of the inscribed angle. And if two inscribed angles open up to the same arc, then they're congruent. Opposite angles in a quadrilateral are supplementary.